Hello, guys. In today's topic, we will be covering calculus in under 20 minutes. Try to. All basics of calculus. Okay. So, to start, there are three parts to calculus there's limits, there's derivatives, and there's integration. I'll just quickly tell you what all does. So, a limit tells us what a certain value approaches as a reference value approaches a constant. Our derivatives help us to find the slope of a tangent line at a curve, and integration helps us to find the area under the curve. Don't worry, I'll be covering all of this and make it quite clear. Now, before we dive into calculus, we need to know a very important topic which is known as functions. Now, what are functions? So, I like to say that functions are a way of representing, are a way of representing a change happening to a certain value, happening to a certain value. Now, what does this mean? This means that suppose we have a value x and x is changing to x squared, or it's multiplying by itself. So the change happening to x is that it's multiplying by itself. How would we represent this change? We could say that if x equals to 2, f of x, which is a function of x, alright, or in short, f of x is equals to x squared, which just equals to 2 squared, which is 4. Alright, I'll define this once more. Okay, functions are a way of representing a change happening to a certain value, x, y, whatever. It could be any value. Alright, and we represent functions by putting a f of x sign in front of the constant. So this could be a function of t, a function of y, a function of a. So all of this means a change happening in x, t, change happening in y, and a. So a functions, when you see a function sign, that means a change in the original value. Alright. Okay, so I'm gonna give you a couple of sums. If x equal to 5 and f of x equals to x plus 3, find f of x. You can pause the video and solve it yourself, but over here f of x would just be equal to 5 plus 3, which equals to 8. Okay, now we can also represent change happening to x or f of x as a variable y or a, whatever variable you desire. So if x equals to 3 and f of x equals to x squared, we can also say that y equals to x squared. So basically f of x would be equal to y. So you represent change happening to x as a variable y. Remember, f of whatever constant or sorry, f of whatever variable you have is a change occurring in that variable. So you could obviously give it another variable value. So a change happening in x can also be represented as y. A change happening in t could also be represented as d, a, whatever. Here's a sum for you guys. If x equals to 2 and f of x equal to y, and the value for f of x equals to x squared plus 4, find y. So y equals to f of x and f of x equals to x squared plus 4, which is just equal to what, x squared plus 4 and x is 2, so that's 4 plus 4, which is 8. So since y equal to f of x, therefore we can say y equals to 8. You can solve this by pausing the video and doing it yourself. That's basically it about functions, but I just have a small thing to go through which would make it easier maybe to understand. We're going to look at functions from a graphical perspective. Alright, we say that x equals to 2 and f of x equals to, suppose, x square, which is just 4. Alright, over here we can tell that f of x depends on the value of x. So if x was 3, f of x would change accordingly. It would become 9. If x was 4, it would become 16, and so on. So therefore we can call x as the independent variable and f of x as dependent variable. Alright, so on a graph we know that the x-axis has the independent variable and the y-axis has the dependent variable. So if we represent this on a graph, this would be x and this would be f of x. Okay, suppose we have a graph that states this. What can we tell from this? We can tell as x increases, f of x approaches infinity. We can see that as this line will go more and more ahead. So as x value keeps on increasing, f of x will approach infinity, as we can tell from here. I just wanted to make that clear, as this would clear the concept of functions for many people. Alright, now we're moving on to the first main part of calculus, which is limits. Now, what are limits? I'm gonna lead with an example. We have a train, alright, which is approaching a station. Okay, and of course this train will approach the station in a certain time, call that t, and there's also a certain distance between the train and the station, we call that d. So over here, can we say as the time decreases for the train to reach the station, the distance between train and the station also decreases? So therefore, as t approaches 0, as time approaches 0, distance also approaches 0. Alright, now we can suppose we assign t as the value of x and d as the value of f of x. What would this mean? This means as x approaches 0, f of x also approaches 0. Now, to represent this using limits, we use LIM, which is short for limit, as x approaches 0 of f of x equal to 0. What does this mean? This means as x approaches 0, the maximum value that f of x can go to is also 0. Maximum value or limit. So the limit of f of x as x approaches 0 is equals to 0 in this case. Alright. Now I'll go with an example sum. Suppose we have the limit as x approaches 2 of x squared plus x. What do you think this would be? You can pause and solve. Okay, you can substitute the x values. So this would just be 2 squared plus 2, which equals to 4 plus 2, which equals to 6. I'll give another example. The limit as x approaches 5 of x minus 3 over x minus 2 equals to what? We can sub in the values 5 minus 3 over 5 minus 2, which is just 2 over 3. And that's the answer. Alright, but what if we have a special case, in which we cannot evaluate the limit? So suppose the limit as x approaches 2 of x squared, hold on, let me just decrease this a bit, of x squared minus 4 over x minus 2. Alright, if we directly sub in the value of x here, this would be 2 squared minus 4 over 2 minus 2. We can see even in the denominator we get 0, so the value is undefined. What do we do in this case? In this case, we use factorization to evaluate. Alright, so x squared minus 4 over x minus 2. What can we rewrite this as? We can rewrite the numerator as x plus 2 multiplied by x minus 2, because 4 is just 2 square. My bad. 4 is just 2 square. So we can rewrite this as x plus 2 over x minus 2 divided by x minus 2. These two will cancel. We are left with the limit as x approaches 2 of x plus 2, which is just 4, because you can sub in the value. Okay, there's another method to do this. Suppose we'll take the same example, the limit as x approaches 2 of x squared minus 4 over x minus 2. Alright, over here we can see that x approaches 2. That means we can take the x value as something close to 2, suppose 2.1. So if we take the x value as 2.1 and evaluate this, that would be 2.1 squared minus 4 divided by 2.1 minus 2. This is equals to, let me just plug it in my calculator, 2.1 squared equals to 4.41 minus 4 over 2.1 minus 2 is just 0.1. So 4.41 minus 4 equals to 0.41 divided by 0.1, which is equals to 4.1. Alright, over here we can see that if as we've taken the x value close to 2, we get the value of this function close to 4, and our answer which we got using factorization was 4. So by this we can tell that as x approaches 2, this function approaches 4. Of course we can find a value closer to this by using the x value as 2.01. If we do that, we'll have 2.01 squared minus 4 over 2.01 minus 2, which when you plug it in your calculator, you will get as hold on, you will get as about 0.04 divided by 0.01, which is 4.01. So even a closer value. We can clearly see that as x approaches 2, that function, let's call it f of x, approaches 4. And that's how you could evaluate a limit when you don't know, when you can't use direct substitution. Alright, I'll give another example. Suppose we have the limit as x approaches 2 of x squared minus 4 over x squared minus, no wait, hold on, over x minus 2, which is the same example as here. I'll just quickly rewrite this so you can understand it in one page. Alright, so this would be equal to the limit as x approaches 2 of x plus 2 multiplied by x minus 2 using the algebraic rule and x minus 2 cut. So this equals to the limit as x approaches 2 of x plus 2, which just equals to 2 plus 2, which equals to 4. Also you have to remember, when you sub in x as 2, you have to stop writing this limit expression. Okay. Next topic we have is, which is our second topic in calculus, derivatives. Alright, what are derivatives? Derivatives, like I mentioned in the start of the video, are used to find the slope of a curve using a tangent line. So the derivative of the y value at this point equals to the slope of this tangent at this point. Okay, so there are a couple of derivative rules that you should know, but that was the main concept behind behind the derivatives. Alright, so first derivative rule is the power rule. So the derivative, this sign represents derivative of suppose we have the derivative of x squared, or I'm gonna write the law directly, of x raised to n. This would be equal to nx raised to n minus 1. That's called the power rule. Suppose we have the derivative of x squared. This would just be equal to 2x raised to 2 minus 1, which is equals to 2x. Or suppose we have the derivative of a function x cubed. This would be equal to 3x raised to 3 minus 1, which is just 3x squared. Remember the power rule. power rule, which is the most common used rules of derivatives, is the derivative of x raised to n is equals to nx raised to n minus 1. Copy this down in your notes. Okay, now suppose we have a slope of a curve at this point, and the y value here is suppose 4. How would you find the derivative of y? Alright, what do you think this would be? We have 4 raised to 1, or let's define this as 4x raised to 0. What would this be? Using the power rule, we get 0 here, so 4 I'll make it simpler for you guys. The derivative of any constant is 0. One second, guys. Okay, as I was saying, the derivative of any constant is equals to 0. So if we have the derivative of 4 equals to 0, 3 0, 2 0, and even 1 0. And yeah, okay, now suppose we have, as I was saying, a slope. I had taken the wrong example there, actually it's my bad. Alright, suppose the y value here is equal to 2 squared, so the derivative of the y value would be equal to 2 times 2 is to 2 minus 1, which is 4. Using the power rule, we get this answer. Remember, how did we get this? Okay, so we have 2 squared. This we can, so this 2 will come here, because the, as power rule states, x raised to n is nx raised to n minus 1. So x raised to n, over here this is n, so this n comes here, so this 2 and multiplied by x, which is just 2 raised to 2 minus 1, which is 4 when you calculate this. So the slope at this point is equal to 4. Alright, that's mostly it about derivatives.